Now let's look at some radical functions. A radical is anything that has a root in the equation, all right? So a radical function will have a root. This power n can be anything. Now, I'll remind you, on a square root, you don't put a number there at all. This would be the square root, but any root after a square root, you put the value there. So it might be a third root, a fourth root, a fifth root. If there's no value, you assume it to be a 2. Now, here's some rules with it. If you have a root and the power is even, it will not exist. Does not exist on the left side. I'll go ahead and write that out. Does not exist or when x is less than 0. Now, if the value is odd, it will exist. Notice over there. And here's one thing they do not include that they should. If this happened to be an even power on the inside, so if the root is odd, it'll exist on both sides of the graph. But if the power on the inside is even, it would actually reflect and go this way. All right, so that can occur. I'll give you an example. A third root of x squared would have this piece and a reflection going this way. But if this x became a 1, like that, then this would go back the way they have it graphed. So that's just a little rule for you to know. So let's look at a couple of these pictures. Here, this is another way of writing. That's a monomial, but you could rewrite this as the fourth root of x to the fifth power. We're going to say that this will not exist on the left. So it does not exist when x is less than 0 because this is even here. Okay, this part tells me it does not exist on the left side. So let's look at the picture. And here it is. Another thing is, notice how it curves upward. It curves upward because 5/4 is greater than 1. So I want to note that on here. It doesn't ask you to find that, but curves upward because 5/4 is greater than 1. Okay, if it were equal to the power of 1, it would be flat. If it were less than the power of 1, it would curve downward. Okay, that's why it curves upward, though. 5/4 is greater than 1. So if we want to do domain, we just said the domain would exist from 0 to infinity. It would not be all reals because, once again, this denominator here is even. All right, the range, it would be somewhat similar. You know what? Let's go back to the same practice. I'll pause. You try to fill in. All right, so there they are. You can copy those down, pause the video if you need. The one thing I'll point out is over here, this limit, you would say it does not exist as x approaches negative infinity because the graph isn't over there. So you just put does not exist. That's the one thing new there. All right, let's try this one. Okay, this time I see that here I got an odd denominator. So first, let me rewrite this. You could write this as 4 times the fifth root of x to the negative 2 power. Or a better way of even writing it is, since it's negative, let's rewrite it as 4 over x to the 2/5, which then later would become 4 over the fifth root of x squared, which again you could rewrite because we don't usually leave a root or radical in the denominator, and this is just getting crazy, would be 4 times the fifth root of x squared all over, when you make that radical disappear, you multiply it, top and bottom, get rid of it, and this would become, I'm sorry, I'm messing up here. This should be, it would become x on the denominator, but this wouldn't be to the 2/5, it would become to the 3/5. We'll learn how to do this part later. It's called rationalizing the denominator. You multiply to get rid of this, and it has 2/5 power, it needs 3/5 power. So if you multiply by 3/5 power, that becomes 1 whole power, and this now would have 3/5 power. Don't get carried away with that. Let's just talk with some general rules. This is odd on the denominator, so it'll exist on both sides. Because of this 2, it'll reflect on both sides. So let's go to our picture first. I deleted the one from the slide because it was just wrong. The book didn't do it correctly. So let's check this out. It'd be 4 times x to the power of -2/5. Press enter, and there's your graph there. I'm going to zoom this way just a little bit so you can see the picture. Now you can see what the graph looks like. Now, as I pointed out, from over here, since I have x in the denominator, that's why I have a break in the center. Because this 2 is even, it reflects, but because the 5 is odd, it does exist on both sides. So that's kind of some rules. It's positive, the 4, that's why it's up here as a positive. All right, I'll let you do domain and range. I'm going to pause the video and fill in the rest. All right, here's the values. You can copy down. Now you can try one.